Double check questions. First section of 5.2, find the exact values of each part. So again, since they're saying exact values, that means I want your, radicals, etc. Since this is the 30, 60, 90 triangle, remember, hypotenuse is always twice. Oh, here, let's do that here. I have a 30, I have a 60, I have a 90 triangle here. This is your short leg. This is your long leg. This is your hypotenuse. The hypotenuse is always equal to twice your short leg. Long leg is always equal to your short leg times √3. So that makes this up here. Z is going to be 16 because that's the hypotenuse. And your short leg's 8. So I've got, this is going to equal 16. This then is going to be 8 √3. On a 45, 45, 90 triangle. So two things are equal there. You get 90 here. The two legs are going to be congruent because you've got an isosceles triangle. And then this is going to be your hypotenuse. It's going to equal leg times √2. So since your leg is equal to 8, your other leg is going to equal 8. And W is going to equal 8 √2. So again, very much a problem that you guys would have done last year. For this one, you're just going to find the reference angle for an angle of 200. I'm skipping B because you just type that in your calculator. Make sure you're in degree mode, press mode, make sure degree is highlighted. For the reference angle for 282 degrees. Remember, reference angles are always made to closest horizontal. So in this case, and again, this is the part that seems to throw some people. Every 90 degrees you go here. So 282 degrees is in quadrant 4. So that means you got this over here. This is 282 degrees. You want this angle right here. This is the nearest horizontal. Okay, so in that case, we're going to go 360 degrees minus 282 degrees. So then you'd end up with 78 degrees. Now, it's not just equal to 360, because depending upon which quadrant you're in, you're going to do different things. So like, for example, if I was in quadrant 3, let's say the angle was equal to 220 degrees. That would be in quadrant 3. So you have this angle right here. This is 220 degrees. Okay, I want this angle. Again, common sense. This part is 180 degrees. What makes up the balance? That's going to be 40 degrees. Okay? Draw out the picture, use your head. Give the exact value of 6 strength functions for 405 degrees, rationalize denominators if necessary. This is coterminal with what? All of these are always going to be based off of 30, 60, 90 triangles, or 45, 45, 90 triangles. And you want this to be between 0 and 360 degrees. Okay? So 405, subtract off your 360 degrees, comes up with a 40. It's coterminal with a 45 degree angle. So when you set this up, you're in quadrant 1. You have 45 degree angle here, 45 degree angle here. Now the big question is, now what's the sides worth? And the answer is, it really doesn't matter what the sides are worth, because you know the relationship. You know that this is a 45, 45, 90 triangle. So this is leg square root of 2. Now if you want to put numbers in, you can go ahead. But I mean, so it could be 10 and 10 and 10 root 2, 5, 5, 5 root 2. You could go 6 root 2, 6 root 2, those are 2 legs, and then get 12 as the other one. Because what will end up happening is, let's say if you decide, okay, I'm going to make this 2, I'm going to make this 2, and I'm going to get this as 2 root 2 then. So then for sine, if this is theta, actually sine of 405, okay, it's going to equal 2 over 2 root 2. This is opposite over hypotenuse, right? Opposite over hypotenuse. So the 2's are going to divide out, and when you rationalize this, then when you get root 2 over 2. Now, let's, just for grins, let's say I had done one over here. Well, actually here, we'll even just do it generically. If I have leg root 2, okay, that sine is going to equal leg over leg root 2. Those are going to divide out, and I still have the same thing as 1 over root 2, same thing as you did. Okay? So it really doesn't matter. Cosine of 405 is going to be the exact same thing. So that's going to become root 2 over 2. Tangent of 405. That was really nice. Super intelligent. So that's just going to be leg over leg, so that's going to be 1. And then for your cousin functions, cosecant, which is based off a sine, which is just going to be the reciprocal of that, so that's going to be root 2 over 1, or root 2. That's going to be the same thing for secant, because it's the same thing. And then cotangent, luckily and nicely, it's the same thing. The reciprocal of 1 is 1. Okay, so again, it's all going to come back to a 30, 60, 90, or 45, 45, 90 triangle on those. By the way, theta interval, we did this one in class. So again, big thing here, remember, is because of this, sine is positive. Okay. And again, I'm just going to help you set this up. Okay. Opposite sides are for sine. So this is my opposite. This is where my opposite side is plus. This is where my opposite side is plus. Opposite side is negative here. I'll go 2 p's. That over here. Okay, my adjacent side is positive there, and it's negative over here. And hypotenuses we really don't at this point care about too much because those are always going to be positive. And so because of this, so sine is going to be bigger than 0 in quadrant 1 and quadrant 2 because my opposite sides are positive and positive. Okay, if I asked you for cosine is negative, where is my adjacent side negative? Oh, my adjacent side negative is over here in quadrant 2 and quadrant 3. So that means it's going to be quadrant 2 and quadrant 3. And that's where you're going to end up using, you're going to find your base angle and then you're going to reflect it in the new one. So in this case, theta is going to equal the inverse sine, because to undo sine you have to use the inverse sine. Not negative sine, not sine to the negative first power, it's the inverse sine, period. So when you type that into your calculator, you're going to end up getting an answer of, make sure you're in degree mode as always. So you're going to end up getting an inverse sine of about 40 degrees, if I remember correctly. Should have just recorded this in class. Thousandths place, 3 decimal places. All right, so sine is positive in quadrants 1 and quadrants 2. Okay, so here's quadrant 1, here's quadrant 2. X-axis, Y-axis. So this is going to be 40.645 degrees. That means that in quadrant 2, you're going to get the same thing mirrored over. It's going to be mirror images into the other quadrant that you're talking about. So that means that this is 40.65 degrees. The other angle that we want, so this is one answer. The other answer that we want is, again, going from the initial side up over to here. So that's going to be 180. That's going to be balanced. They're supplementary, so you're going to have 180 minus the 40.645. So you're going to end up with an answer of 139.355 degrees. And that's going to be the other answer that theta could be. Okay. Cosine would be something similar to that. So I'm going to pause here and kick over to the other one in a second.